Hey YouTube, welcome back. Today we have problem on number 169, majority elements. Given an array called nums of size n, return the majority element. The majority element is the element that appears more than n divided by 2 times. You may assume that the majority elements always exist in this array. Okay, so I guess the problem description is quite straightforward. If we take this example, we have nums and we have this array, and the majority is 3 because basically the 3 is available in many indexes, and all these indexes combined they are bigger than n divided by 2. So if that was the case, how we solve this problem? I would say there are 3 ways to solve this problem, and I'm thinking about doing all of them in this video. We could start by first. We could just if we want to find the majority, we can just find like sorting. I guess the time complexity it will be all n log n. Like if we sort the array, the majority element will always be at the index n divided by 2. So how this work? Let's take this example. Let's take this example as example, for example. So if we have this array and we decided to sort it, okay? If we decided to sort this array, we have 2, 3, 3. The element that which will be in the index of n divided by 2, the index of this the index of this value will be always the majority number. So basically any index n divided by 2, I guess 3 divided by 2 is 1.5, and if we just floor it, it will be 1. So we'll have 3, and this will always be the majority element. If we did this in this here, we sort it, it will be like 3 ones and 4 twos. If we find the element that is the index in divided by 2, we will find that it is the majority element. So sort, we will have A and B and A minus B. By this, we're sorting the array, and after that, I will return math nums. Sorry, not math nums in the index of math dot floor nums dot length divided by 2. And yeah, let's run. It did work. Let's submit it. It did work. Okay. So we have this solution at the beginning. It's pretty simple. We sort the array, and after that, with the index in basically in the element that lives in this index will be always the majority number. But if you are in an interview, I guess your interviewer will ask you for other solution, because this solution is only 2 lines of code. It might sound like a heck. So we can use like a hash map, like we can use a hash map or JavaScript map to count occurrences of each number and return the number that appears more than n divided by 2 times. I guess this solution is easier to describe. So let's start here. Let count map equals new map. I would say for I will make a for of loop. Let num of nums. Okay. Also, I will add to the map. So count map. Let's call it map, only map. So we'll have map dot set. We set the number, and we want to make sure to if the number is already available in the map, we add 1 to it. If it's not there, we add 0. So not 0. Okay, I will show you in the code. So map dot get num, if the actual number in the map, or we will add 0. So basically here we're trying to get the value. We're trying to get the value of the num if the actual number is available in the map. If the map, we get the value. Otherwise, we take 0 plus 1. So we make sure that when we find the number more than one time, we will just try to add to it. So right now, yeah, it's like that. And after that, I'll create if statement here. I would say count, not count. We call it map dot get. We have num map.get num. If map.get num, if this one is bigger than nums dot length divided by 2, that means we find our number, so we return the num. And yeah, that's it. Let's run and see if it works or not. It works. Let's try to run it. It works as well, perfectly fine. The time complexity, I guess it's off in because we loop through array once. The space complexity is O of n as well because we store counts in a hash map. There is like other one, it's called the Boyer-Moore voting algorithm. Like since the majority of elements always exists, we can use a voting method like keep candidate and a count. Like we can just traverse the array. Like if the count equals 0, we set the candidate to the current number. If the current number is the candidate, we increase the count. Otherwise, we decrease the count. Since the majority element appears more than n divided by 2 times, it will always remain the final candidate. How this will work? Okay, let me try to restructure everything here. So, okay, so I'll create a candidate. Let candidate, and it will equals null. And also I will create count, and the count will equal 0. And I create a for off loop. So for let num of nums, and I will continue here. So I'll say if count equals 0. As I said before, if count equals 0, we set the candidate to the current number. If count equals 0, the candidate will equals num. Okay, and we will increase the count. Count will plus equal. Okay, so it will block equals a specific value. So we're saying that if num equals the candidate, if that was the case, we will add 1. Otherwise, we take 1. Okay, and we return the candidate. So yeah, this is how it works. So the majority of element will appears more than n divided by 2 times. So it will always outweigh all other combined. The time complexity, I guess, is O of m, and the space complexity is O of 1 because we only uses a few variables. So let's run and see if it worked or not. Let's submit. Yes, it did work. Yeah, it did work, and we did a pretty good job with this algorithm. So yeah, we have 3 different solutions that solve this problem. I guess this might be the hardest one to understand, but I guess it's pretty obvious if you just try it by yourself and you think about it. Since the majority of the element appears more than n divided by 2 times, so it will always outweigh all the other combined. So we will make sure that when we do this, the candidate as well, the count like that, we will make sure that the count will always, and the count will always will pick the right candidate or the majority element. So yeah, that's it for this video, and see you in future videos.